Let's say if we were asked to find the exact value of sine of 5 pi over 12 without a calculator. Now, if you were just to look at your unit circle, you'll realize that, wait, 5 pi over 12 ain't in my unit circle. So how the hell am I able to do this? Well, luckily, you got something known as an angle sum formula. So let's write this all out. So I'm not going to prove this in this video. I'll kind of make a proof video in another day. But basically, sine of a plus b is equal to sine of a times cosine of b plus cosine of a times sine of b. Okay, so you're kind of doing like a switcheroo here. Sine of b. Okay. So how can we use this formula to solve this problem? Well, let's rewrite it. So let's rewrite sine of 5 pi over 12. All right. Let's rewrite this. Okay, so 5 pi over 12, I can rewrite this as sine of 3 pi over 12 plus 2 pi over 12, right? And 3 pi over 12, that's the same thing as sine of pi over 4. And then this is going to be plus 2 pi over 12 is pi over 6. Pi over 6. So now notice how I've rewritten sine of 5 pi over 12 as sine of pi over 4 plus, sine of pi over 4 plus pi over 6. All right. Now I can kind of apply this formula to this thing. So let me just rewrite this using the formula. So if I let this right over here be A and this right over here be B, remember, this formula right over here is the sum of two angles, right? So if I have these two angles added together, and then I'm taking the sine of these two angles, right? Notice how there's a parentheses around it. This is what I get. This right over here is the sine of an angle plus an angle, right? So using the formula, we get sine of A plus B is equal to sine of A, so sine of pi over 4, sine of pi over 4, times cosine of B, so cosine of B is cosine of pi over 6, plus cosine of A, well, we know that's pi over 4, times sine of B, so sine of pi over 6. Now, the thing about sine of pi over 4 and cosine of pi over 6 and all of these is now we can use our unit circle to figure out the values. You see, we've rewritten sine of pi 5 pi over 12 in a form where we're actually able to use the unit circle to sort of calculate out these values. Now, the trick for these types of problems is when you want to find out kind of the sine of, one angle plus another angle, what you got to know is that these two angles right over here, notice how they're either a multiple of pi over 4 or they're a multiple of pi over 6. So whenever you're trying to do these types of problems, you have to break this angle right over here into two smaller angles that are either a multiple of pi over 4 or a multiple of pi over 6, because that way you can use the angle sum formula to actually figure out the exact values. And we know what these values are. When we create a pi over 4 angle on the unit circle, I don't know why I made this transparent. I don't know what I did. All right, there. So when I create a pi over 4 angle, remember pi over 4 is kind of the same thing as a 45-degree angle. All right, so remember that this hypotenuse right over here is going to be 1, and when you create a pi over 4 angle, well, notice how this is just a 45, 90 right triangle. So this side right over here is going to have root 2 over 2. This side's going to be root 2 over 2, right? And, if y'all don't know that, make sure to check out my unit circle video. But anyways, sine of an angle basically represents the y value for this triangle. So sine of pi over 4 is equal to root 2 over 2, right? Because it represents the y value of this triangle. Now, what's cosine of pi over 6? Well, remember that pi over 6 is the same thing as a 30-degree angle. All right. So if you want to, you can convert it into degrees if it kind of helps you kind of see this better. But notice how this is just going to be a 30, 60, 90 right triangle. Now, cosine is represented by the x value for this triangle. So let's see here what I have. This is going to be 1/2, and then this is going to be root 3 over 2. Remember, the side opposite 30 is always going to be half the hypotenuse, and the side opposite 60 is always going to be radical 3 times longer than the side opposite 30. So cosine of pi over 6 represents the x value, so that's just going to be root 3 over 2, right? And that's what we have here. Now, what's cosine of pi over 4? Well, once again, we can use this diagram. Cosine is, once again, representative of the x value, so it's just going to be root 2 over 2. And sine of pi over 6, well, sine is represented by the x value in this triangle, right? So then this is just going to be equal to 1/2. All right, now let's just simplify things. So root 3 times root 2, root 2 over 2 times root 3 over 2, that's just going to be root 6 over 4. And this is going to be plus, right? Can't forget the plus. These two things multiplied together is just going to be root 2 over 4. So simplifying this, because we have a common denominator, we're just going to get root 6 plus root 2 over 4. And that's going to be our fully simplified answer. So whenever you're doing these problems, make sure you know what you're doing with your unit circle, and make sure you know how to break up this angle right over here into multiples of pi over 4 and pi over 6. With more practice, it'll be kind of easier. It'll be easier for you to break up this type of term.